Okay, thank you for joining. My name is Mr. Jones, and I'll be your college algebra teacher. So this should be your first video here watching for my flipped classroom. It is lesson 0 or chapter 0.1. So I'll just go through some notes, and if you have any questions, just let me know in class about how this exactly works out. So if you don't already, I will tell you again, it'll be really helpful at THS Mr. Jones. I'll post updates and links onto Twitter there for you. Okay, so we're going to start chapter 0.1, which is talking about real numbers. And I first want to talk about the number system. So the number system is comprised of two different kinds of numbers. So the one I'm going to talk about for now are the real numbers. Okay, you also have this set of numbers that's related but not really, called complex. That actually surrounds them both. And in here would be imaginary. Okay, but we're specifically going to talk about our real numbers. And inside our real numbers, we have two categories. We have rational, and we have irrational. Okay, so your real numbers are split up into two categories called rational and irrational. Inside your rational, we have a subgroup called integers. And inside of that, we have whole numbers. And then even inside of that one, we will have counting numbers. Okay, so let's start with the most basic. A counting number starts at 1 and goes up. So it would be 1, 2, 3. It is what you count items by. Okay, whole numbers will start at 0, include your counting numbers. So 1, 2, 3, 4, and all the way up. Okay. Integers. Okay, integers will be positive and negative whole numbers. Okay, so for an integer, we would say they start at negative infinity, so negative 2, negative 1, 0, 1, 2, and on up. Okay. A rational number is any number that can be put into a fraction. Okay, so rational numbers will include all of these, but also it might have a half. It might have negative 19 over 7. It could have negative 1/3. It could have 3.6 repeating. Any number that can be put into a fraction is a rational number. If it cannot be put into a fraction, it is called an irrational number. So we have such things as the square root of 2, we have pi, we have I, we have e, and we have just a ginormous decimal here, and it keeps going on forever. So things that cannot be put into a fraction are irrational. Okay, and then I don't want you to worry about imaginary and complex quite yet. We will get to there later. But also, all of these we can graph on a real number line. Okay. All right. We have a couple of things. We have two things. One's called rounding, and the other thing is called truncating or truncation. Okay, so with truncation, you cut off numbers after a certain decimal. Okay, so if I say truncate to the third decimal place and I have this number, let's say I have 3.141598. Okay, and I say truncate to the third decimal, so that's 1, 2, 3. You just ignore this. Okay, so it's 3.141. Rounding, okay, with rounding, that's when you look, if it's 0 through 4, you don't do anything. If it's 5 to 9, it moves up 1. So again, so nothing. And this is up. Okay. And just know that in these videos, you can stop or rewind or do whatever you want in order to keep caught up or to have me re-explain something. Just rewatch it. Okay, so if I have 3.141598, and if I do it, if I round it to 3 decimals, we're going to look at this one. This is the third decimal, so we look at the one after. It's a 5, which moves this up to 1. So 3.142 would be that decimal. So that's rounding and truncating. We normally do not truncate. Uses a little more value sometimes. Okay, so order of operations. Let me give you some of your questions here. Here's your first question, and that is, what is a rational number? Most often students will do this separate sheet of paper. It's much easier to organize all your video questions together. I'm sorry, I should explain that. But I want all your video questions together, maybe separated by video. So there's your first question. Okay, so let's talk about the order of operations. Order. Okay, and I see a lot of posts on this about Facebook. They throw up some super easy looking problem and they're like, solve it, and everybody's arguing back and forth about what the answer is because they don't really understand what the order of operations are. So all of you have probably known order of operations as, please excuse your Aunt Sally. Okay. Parentheses, exponents, multiply, divide, add, subtract. Okay, well this messes everybody up because they just want to go straight down the line. Okay, this is really not a good way to know order of operations. Okay, so I want you to know it and kind of use it as GEMD. And you can put whatever words you want to that. They're very similar to what's over here. First one we have is grouping, which includes parentheses. So you have parentheses, you have braces, and you have brackets. So all of these fall under this category. Components. Okay. And then the MD, that is still multiply and divide. This is still add, subtract. But the problem here is Over here, it looks like you do multiply and then divide. However, over here, if multiplication and division is the only operation, you will do it left to right. So, for example, if I have this problem, if I have 9 divided by 3, 2, okay? Over here, most would say, well, we're going to multiply and then we're going to divide. But you need to, because multiplication and division are the only ones there, you must do it left to right. So really, we're going to take 9 divided by 3, and get 3 times 2, which would be 6. If you did it the other way, it would be 9 divided by, which would be 3 halves, which is completely two different answers. So you need to know it this way. If it's just multiplication and division, you do it left to right. If it's just add and subtract, you do it left to right. So you have to know the left to right stuff. Okay, that will do the order of operations. We talked about expressions and equations. Okay, so let's say we have just a simple equation here. And let's say that. Oh, you can't even see that. Okay, so we have 5x plus 3 equals 9. All right, so we have some parts to this equation. This is an equation. Okay, we have some parts. It's an equation because it has an equal sign. Each side of the equation is an expression. Okay, that's an expression. That's an expression because it doesn't have a variable or anything. We can call it a constant. Okay, but it is also an expression. Okay, if we look at this expression, we can break it down into even more parts. If we look at the 5x, that is called each one of these is called a term, but because this one has the variable, we call it the variable term. Okay, and since this one doesn't have a variable, we call it the constant term. Yes, both of these are constants, and that is fine. Okay, so those are our parts. And if it's an equation, we solve it. If it's just an expression, the only thing we can do is simplify it. Okay, there are a ton of properties that we can do with real numbers. Okay, they start on page 10. And it looks like they're going to end on page 13. Okay, you know all these properties. I'm just going to maybe spit out a couple that are important to us. The first one is the distributive property. Okay, that's just taking this outside term and multiplying it by each one in there. Okay, we have like the commutative property of addition, commutative property of multiplication. Those just say like if I have A times B, that is the same as B times A. We can rotate those around. We have identity property. A plus 0 is A. Multiplication identity is 1. So A times 1 is A. Get itself back. Okay, so we have all these properties that you can look at in the book. I don't think I really need to go over them. Maybe some properties of negative numbers. Okay, if we have a positive divided by a negative, that's a negative. If we have a negative divided by a negative, that's a positive. No matter what size those numbers are. We can kind of do that with multiplication. Negative times negative is a positive. A positive times a negative is a negative. And then you know how to do addition and subtraction with that. Know this, that 0 divided by any number and any number divided by 0 does not exist. Okay, it is undefined. You cannot divide by 0. Here's an important one that you want to know. B equals 0. Okay, you get this in algebra 1 and algebra 2. Then either A is 0 or B is 0. Okay, one of those has to be 0. This a ton in college algebra, so you may put a big square box or something around it. Okay, so I'll give you the rest of your questions here. Okay, so we have, what is a rational number? What are the order of operations? And number 3, explain the difference between an expression and an equation. So I should have gone over all of those in the video. If you don't remember them, you need to go back and watch this video. Okay, now what happens now? Well, you will actually stop the video. If you plan on being in class the next day, okay, so stop. If you are absent or just want to continue to listen to me spiel about real numbers, you can continue to watch. But I am going to go on now and do some example problems. These problems will be done in class, so you do not have to watch this portion. So you can stop watching if you want. If you want to continue watching, you can do that as well. Make sure you have your questions ready to be graded when you walk in class. That should be out on your desk, ready to go and ready to be discussed. Now I'm going to continue over some examples. Okay, I first just want to maybe start off by some simplifying expressions problems. 4 plus 3 times 2 minus 7 times 5 plus 6. Okay, and it's order of operations. So you have grouping, exponents, multiply, divide, add, subtract. Okay, until you get into the groove of being back in school, it's usually a good idea to kind of write them all down. So I don't have any grouping symbols. We're going to multiply, divide. Okay, so I got this one will be 6 plus 4. I have 7 times 5, which is 35, plus 6. Okay, now the only thing I have left is add, subtract. So this tells us we do that from left to right. Okay, so I have 4 plus 6 is 10. Okay, 10 minus 35 is negative 25. Plus 6 is negative 19. Okay, and again, I usually do this a long way on the videos, but if you had a calculator, by all means, that would be good for me. So then we have 7 minus 6 divided by 2 times 3 plus 8. Now this is a good problem to discuss because I don't actually have any grouping symbols, but there is grouping in this. Okay, they've already grouped the top and the bottom together for me. So I need to do the top, which is 7 minus 6, which is 1. And I need to do the bottom. But in the bottom, it looks like we have multiplication first. So that's 2 times 3 is 6 plus 8 over 14. And there's your answer. We will not do anything more with that. So I try to get a harder one here. So 3 times 4 minus 2 minus 2 times 7. Oops, bracket. Okay, so make sure we're following order of operations. On the innermost grouping, so that's 4 minus 2. 4 minus 2 is 2. And then I have times 5 minus 2 times 7. And again, I'm going little by little. So then we're going to do the multiplication. Now, it would be very easy for you to confuse and just cross those two out, but we have multiplication here and here. So that's 10 minus 14. Now, you could distribute if you wanted that. That is okay. But since we have numbers in here, we like to work the inner side first. 14, which is -4, which is minus 12. Okay. So I think we're fairly well on order of operations. We will go back to some expression stuff. So you might see a problem like this. You also might see this, and we'll get more into this later. So they might write it like this and say x is 3, or they might say, what is f of 3? Okay, all you're doing here is you're taking the value that they say they want the variable to be, which is 3, and you're just going to plug it in. 7 times 3 plus 2. 7 times 3 is 20. Sorry, 7 times 3 is 21 plus 2 is 23. Okay. Again, you have all the properties. We talked about the distributive property. That's just taking my 5, 3x plus 5. and taking this in both of those. It doesn't matter how many terms are in here. I could have a 3 plus 5 minus 2 minus x. I could have all that in there. I could still distribute that a into everything, and it worked just fine. Okay, so I think we'll go with distributive property. What you don't want to do is something like this. Okay, this 3 only goes to the parentheses. It does not go to that 3 over there, so be very careful with that. Let's try this problem maybe. -5 plus 7 minus -2. Okay, so I have addition and subtraction, so I got to do that left to right. But I noticed right here I've got a double negative. Those actually make a positive. So you have -5 plus 7 plus 2. So that's -5 plus 7 is 2 plus 2 is 4. Okay. So if you're doing that on the calculator, make sure you're putting it in correctly as well. Okay, we didn't really talk about absolute value, but if we have something like this, okay, these vertical lines, usually they run up higher or as high as your lines on your notebook paper. Absolute value is the distance away from 0. So if we get this here, so I have -3 plus 7. -3 plus 7 is 4. And I want the absolute value. Okay, the absolute value is the distance away from 0. So I'm trying to find what number is 4 units away from 0. So that's 4 and -4. But because we want a distance, the distance is always 4. So 4 is how far away from 0? It is 4. If it was the absolute value -4, well, -4 is 4 units away from 0. So it's always how far is that number away from 0. Okay, let's look at this problem because this problem is done wrong. Okay, so I have this number here. I could distribute, or I will distribute, but when you distribute, make sure that you take this to every term in there. Okay, so it's going to become -2x plus 3y, because a negative times a negative is a positive. So make sure you are distributing into everything. Okay, I got a couple more examples here. Try to use up some of this paper. I hate wasting paper, so it's kind of intermixed. And these deal with fractions. Okay, and just know your properties of fractions. I should have said it at the beginning that you know, what do you need to add or subtract fractions? That's a common denominator. And then how do you multiply or divide fractions? Multiply, you just multiply straight across. Divide, you multiply by the reciprocal. But we'll look at this problem here. So in order to subtract, I must have a common denominator. And the easiest way to do that is to multiply them by each other. So we're going to get 12. So we'll take this one times 4 and take that one times 4. Whatever I do in the bottom, I got to do in the top. And we're going to take this one times 3 and that times 3. So you have 8 over 12 minus 3 over 12. Then you have 8 minus 3 is 5 over 12. And if you could reduce, you would reduce. Now you have 2/3 divided by 4. Well, 4 is 4 over 1. And in order to divide, you're going to take 2/3 and you're going to multiply by the reciprocal. So that's just flipping that one over. So 1 over 4. And then you multiply straight across. So that's 2 over 12, which is 1/6. Okay, if you have a variable, maybe a great quiz problem right here, folks. Okay, you still need a common denominator. So we're going to multiply this by 2 and that by 2. We're going to multiply this one by 5 and this one by 5. X over 10 plus 6 over 10. So we add the tops, so that's 5x plus 6. I can't add them because they are not like terms. And on the bottom, you have 10. And that is your answer. Okay? Now, your suggested problems are on page 15, numbers 7, 11, 19, 35, 39, 43, 55. Now know that these are suggested problems, so they are not required. 63, 71. Yes, it may seem like there's a lot, but it's designed for those who need help. Number 87 is your challenge problem. If you think you really have this topic, you're going to want to try number 87. Sometimes it pops up as a bonus question on the test, or it may be some kind of extra credit that I put in there. Okay, so those are your problems. Make sure we're trying those out. We'll talk about this and go from there. So as always, thank you for watching. This is at THS Mr. Jones signing off.